So in our discussion, I'm focusing on some topics in physics from Form 1 or Form 2. So we are focusing on what we are calling as being momentum. So what exactly is momentum? So momentum has this very simple definition. So momentum, represented by capital letter P, is defined as, or is the product of the mass and velocity of an object. That is what we call momentum. So we can simply say that momentum, in this case, if we look at it, momentum P is equal to the mass multiplied by the velocity of that object, the velocity with which the object is moving. So we can therefore say that momentum is equal to mass multiplied by the velocity, and that is the formula that we use for momentum. So if you look at it in this case, what are the units for momentum? Remember, mass is measured in kilograms and velocity is measured in meters per second. So when you combine kg and meters per second, it will give you kg meters per second, and these are the units for momentum. Remember, you can write these units as kg. If you don't want to write that slash, you can write meters, then s minus 1 there. That is basically the same. So that is the unit in this case, for momentum. Now, other concept that you need to know is that, momentum depends on the mass as well as the velocity of an object. So those are two factors that affect the size of the momentum that you are going to have. Now, for one thing, when we talk about stationary, we can say stationary objects, stationary objects have zero momentum. So stationary object have got zero momentum. That's what you need to remember. Consider an object. Let's say that you have got an object and that object has got a mass of 1000 kg. Now, if this object is actually stationary, we mean it is actually not moving. So if it is stationary, it means that the velocity, if the object is stationary, it simply means the velocity is equal to 0 meters per second. So if you were to calculate the momentum, which is mass multiplied by velocity, so momentum, the mass would have been 1000 kg multiplied by the velocity, which is 0 meters per second. This is going to 1000 times 0 give you 0 kg meters per second. So you can see that the momentum is actually 0. Why? Because the object is actually stationary. In other words, it is not moving. So any stationary object has a momentum of 0. So that is very important, that you need to take note of what we are calling as being momentum. Well, other concept, let's take for example that you have an object, a car of mass. Let's say that you have a car of mass 1200 meters per second, and that car that you have is moving at a velocity of, let's say that it is actually moving at a velocity of 10 meters per second. And the question tells you to say find the momentum. All right. Now, another aspect that you need to remember, which I basically did mention, is that when we talk about momentum, momentum is a vector. So momentum is actually a vector, quantity, meaning that it has got both magnitude and direction. So a car moving, you need to state the direction in which it is moving. Let's say that this car was actually moving, if that is a car that I'm having there, let's say that this car is actually moving going to the right. So it is actually moving going to to the right. Okay, don't worry about my car, but it is moving at a velocity of 10 meters per second. Then what would be the momentum? So remember, it is going in that direction to the right. It simply means that if we were to find the momentum, simply means momentum, start always with a formula. Momentum is equal to mass multiplied by the velocity. So the momentum will be the mass, sorry, we added units, that is wrongly done. Mass is supposed to be in kg, so that's 1200 kg, 1200 kg, then you multiply by the velocity, which is 10 meters per second. It simply means that the momentum is actually going to be, 12,000 kg meters per second. So there's nothing complicated when you're actually finding the momentum. It is actually something that is very simple. Another aspect that you need to remember, let's look at maybe I'll call it as being example number 2. Let's say that you have a tennis, let's say that you have a tennis ball of mass 500. So let's say you have a tennis ball of mass 500 grams, and this tennis ball is moving, is hit towards the wall and moving at a velocity, in this case of 12 meters per second. Then I tell you to say find the momentum. So find the momentum. In physics, as usual, it is always important to list down the data, the information that you have. So remember, you have the mass there, which is 500 grams, but that's not the correct unit. Right away divide this by 1000, and that will give you a 0.5 kg. Then of course, if you look at the velocity there, they told us it is 12 meters per second. So what we want to find is the momentum. So the momentum will be equal to the mass multiplied by the velocity. So it will be the mass, which is 0.5 kg, multiplied by the velocity, which is 12 meters per second. So if you were to get your calculator and try to multiply that, it will be 0.5 multiplied by 12. So this is going to give us, in this case, 6 kg meters per second. So that would be the momentum of the tennis ball. So very important that you simply get to know such aspect. I'll take you back so that I can actually look at a few concepts so that you can actually appreciate more on what we are calling as being momentum. It's not a complicated thing. So I want to talk about what I'm calling as being impulse in this case. So we can simply talk about what we call as being impulse under momentum. So what exactly is impulse? Well, when we talk about impulse, impulse is defined as the change. We can say it is actually defined as the change in momentum. So it is actually defined as the change in momentum. Now, initially, you can have the initial momentum. I'll represent it by Pi, initial momentum. It simply means that it will be the mass multiplied by the initial velocity. You can also have, the final momentum. So meaning it will be mass and the final velocity. You get the point, huh? Yeah, that's what we mean there. So if I told you to find the change in momentum represented by delta P, the change in momentum represented by delta P, this triangle is delta, that means change in momentum. It would have been equal to the final momentum minus the initial momentum. So therefore delta P would be equal to, what is the final momentum? It is the mass multiplied by the final velocity minus the initial momentum would be the mass multiplied by the initial velocity in this case. So now remember, you are dealing with the same object. It's like an object starting from rest, then it acquires a certain velocity we call the final velocity. That's what we are talking about. But here I'm representing using V in both cases, but to differentiate them I'm using initial and final. So you can see what is common there. M is actually common there. So change in momentum, the mass is common. I'll remain with the final velocity minus, in this case, the initial velocity. So that's what we call, this is what we simply call as being impulse. So the change in momentum is what we call as being the impulse. Now remember, also I want you to be aware that this change in velocity can be written as delta v is equal to final minus initial velocity. So where there's v final minus v initial, I can represent it with delta v, change in velocity. So I could have simplified this one and say delta p, change in momentum, is equal to the mass multiplied by the change in velocity. But remember, the change in momentum is what we call as being impulse. So sometimes impulse can also be defined. I want you to again to redefine impulse. We can also define impulse as simply being, it can also be defined as the product of the force. We can also say the product of the force acting on an object. So the product of the force acting on an object and the time period. So and the time period in which you know the force acts. So that is what we also call as being impulse. So the product of the force, in other words, you know, impulse, which I'm representing by delta p, is going to be impulse is simply equal to the force multiplied by time. That's what we mean. So the force acting on an object and for how long it is going to be acting on that object. So that is what we simply call as being you know, impulse. That's another definition. Now I want to basically highlight this so that you are able to see, you know, this definition that I've actually, you know, given you there. I want you to see, you know, this, you know, definition there. So I'm simply saying that delta p is equal to force multiplied by, you know, time. I can make f the subject of the formula by dividing t. I also do it that side, meaning that force will be equal to change in momentum divided by time. So you can see we can find the force, you know, acting on that object. But remember, you say that momentum is equal to mass, if you want change in velocity divided by time. I hope you remember from the previous one, we say change in momentum is equal to mass final minus the initial velocity. But this, I actually represented it by change in velocity delta v. This is what I've actually just done there. Now, can I actually try to misbehave and show you something? If you remember, acceleration is the change in velocity divided by time. So you can see here what we are having there. That is simply v over t is representing acceleration. So you can see force is equal to mass, and that one is simply the acceleration. So you can see what it has given us. It has actually given us what we call as being Newton's, you know, second. It has actually given us Newton's second law of motion. For some of you that I'm teaching, you remember I love to say N to L. So Newton's second law of motion. So you can see where we are coming from. So it's very important. So watch out for some more videos under this one, because under this one I'm going to come and teach you about what we call as being collisions. What we call, it's either, you know, elastic collision. So we'll look at elastic collision and what we call inelastic collision. So inelastic collision. So watch out, please. You can learn more with Mr. Nyendwa. We also offer private lessons in Livingstone and online lessons. So you can contact us on the number 0976 298511. You can even WhatsApp me or give me a direct call, so that you are able to learn with Mr. Nyendwa. So you'll be able to learn with us, and we'll be able to guide you properly in physics, chemistry, biology, mathematics, addition mathematics, be it, will be able to guide you properly. Thank you so much for watching, and watch out some other videos that are there on my channel. Then you can actually get to learn a whole lot. Thank you so much for watching.